So our essential understanding for this section is you can use logarithms to solve exponential equations, and you can use exponents to solve logarithmic equations. Okay, that's ultimately what we're coming to at the end of this section. However, we're going to start off with just exponential equations. Okay, so to solve exponential equations with the same base. Okay, key word here is that they have the same base. Okay, in case you didn't understand why it was capitalized, that's our key word. So first off, you have to write the base in prime factored form, which means that if we were to break this number down, what would be its prime factored form? Okay, so that each side of the equal sign have the same base. Okay, then we're going to set the exponents equal to each other and use inverse operations to solve for x. Okay, when we're using inverse operations to solve, that's SADMAP. Remember, you're doing PEMDAS backwards. And then you're going to check yourself. Check yourself is, of course, it's an optional step. But when you ask me if you got something right, I'm going to say, did you check yourself? Okay, so just be mindful of that. So these are our 3 simple steps. Write in base form, same base form, make the exponents equal to each other, and then check our work. Okay. So step 1, we're going to start off hard with a fraction. All right, we're going to come out of the gate strong. We have 1/16 equals 64 to the 4x minus 3. Okay, 1/16 is a fraction. To change a fraction into a non-fraction, remember that means that you have to make the power of it negative. So you need a negative exponent. So this is going to be written as 16 to the -1. That's how you undo the appearance of a fraction. So now we have 16 to the -1 equals 64 to the 4x minus 3. All right. It says that you need to have the same base. So when you were talking about the same base and it says factored form, if you're going to factor this, think about 16. If I was to break down 16, that would be 4 and 4, right? 2 and 2. So 16 equals 2 to the 4. Agree? All right. Or I could do 64. So 64 breaks down to be 8 and 8, which breaks down to be 4 and 2, which breaks down to be 2, 2, 2, 2, right? How many 2s do I have? 1, 2, 3, 4, 5, 6. So 64 is 2 to the 6. That's what it says. That's what it means by being in prime factored form. How do we feel about that? About your factor trees? Okay. So that's what we're going to do. So 16 is now going to become 2 to the 4. And you're going to protect what was already there by putting in parentheses. So we're putting -1 in parentheses. Equals 64 now becomes what? 2 to the 6. And we're going to protect what was already there, which was 4x minus 3. That is what step 1 wants you to do. What are your questions about step 1? No questions about step 1? All right, step 2, now that your bases are the same, all you're doing is taking your exponents and setting them equal to each other. So if you take 4 to the -1, set it equal to 6 times 4x minus 3. Is that just not a basic algebra problem for you to solve for x? It is, right? So what is step 1 to start solving for x? We're going to multiply stuff, right? So we're going to multiply. 4 times -1 is -4. 6 times 4 is 24. 6 times -3 is -18. What do I need to do to get x by itself now? Move 18. So I'm going to add 18 to both sides. And that gives me, what's -4 plus 18? 14. 14 equals 24x. What's the last thing to do? So x equals 14 over 24, which reduces to 7/12. Good job. So my answer is 7/12. All right, so let's zoom in on the algebra. So all we did for the algebra again was we multiply, which meant we distribute. After that, then it just became a two-step linear problem, right? We add, then we divide. So we added 18, and then we divided by 24. We got 14 over 24, which reduced to 7/12. Okay, so that's step 2. Because once your bases is the same, step 2 says all you have to do is focus on the exponents. Okay. All right, so step 3 is where you check yourself. That's where you're like, ooh, I'm not sure if I really did this right, right? So step 3 is you go back to the original problem. And where X is, you plug it in to see if it makes a true statement. So if I plug in 7/12, do I get a true statement? Okay. And we're just going to use Desmos Scientific to check ourselves. So I'm going to go to Desmos Scientific really quick. And I'm going to put in 64 to the, what was it? 4 times 7/12 minus 3. Ooh, minus 3. No, I need the 3 to be at the top, bro. Minus, no, stay up there. Why won't my 3 stay? Okay, let's try that again. Times. It won't stay up there. 4 times 7/12 minus 3. I did it. It did it itself. I'm just going to do it in parts. I'm doing it in parts. So we have 4 7/12 minus 3. Bam. Going to turn that into a fraction by just clicking the little fraction bar. Gives me negative 2/3. So now I'm going to do 64 to the negative 2/3. Hit enter. Turn it into a fraction. Is that what I needed to be? Yes, it equals 1/16. So what does that tell me? I did it correct. Yay. You're a genius. All right. So that's what it means to check yourself. All right. So let's do this again. So on this one, we have 4 and 8. So step 1 is to make the same base. So if I was to break down 4, that becomes simply what? 2 squared, right? If I was to break down 8, that becomes 2 to the 3rd, correct? So now we have 4. I'm sorry, not 4. 2 to the 2nd. So 4 is 2 squared, and we protect what was already there, which was 4x equals, and what is 8? 2 to the 3rd. So that's step 1, making sure that they already have the same base. Do they have the same base? Yeah. So step 2 is all you have to do is take the exponents and set them equal to each other. Now, what do you need to do to get x by itself? Multiply. So we have divide by what? Divide by what? 8. So what does x equal? 3 over 8. I can't reduce it anymore, right? So again, checking myself. So to check yourself, you would plug in 4 3/8, which is going to give me 4 to the 12/8. So I'm going to go to my handy dandy calculator and see if 4 to the 12/8 gives me 8. So I'm going to try to go back to my calculator. open it, and we put in 4 to the 12/8, hit enter. Do we get 8? Yay, we did it. That's all. Yes. So funny that you asked this, because someone asked this last class. I don't know what your career is going to be in your life, but the main purpose of math, especially in high school, is to help develop your brain skills. So it's literally its purpose is to help you with problem solving, pattern recognition, and just general cognitive understanding to help develop your frontal lobe. So it's to make you smarter overall. Yes. Oh, it does. I've witnessed it. All right. So before we leave, I would like for you to do this one. Here's yours. Here's yours. I believe in you. All right, so let's check and see how you did. So 125, what did that factor down to be? 5 to the third, good. And gives you 9x minus 2 equals, what did 25 factor down to be? 5 squared. All right, so now you have the same base. So step 2 is you're taking your exponents and setting them equal to each other. So you have 3 times 9x minus 2 equals 2. You're going to distribute. You're going to distribute. So we get 27x minus 6 equals 2. And then we're going to add 6. And we get 27 equals, x equals 8. And then we divide by 27. So you should have gotten x equals 8 over 27. And then always do what if you don't believe in yourself? Check it. All right, please stay in your seat until I dismiss you. And what if they have different bases, right? What do you do? Well, here are the 5 steps that you're going to follow when they have different bases. You're going to write the original equation, and you want to make sure there's only one term on both sides. So it needs to be one term equals one term. Okay, so that's thing number 1. You want to make sure there's only one term on both sides. And then you're going to take the log using base 10. So common log. So we're going to stick to common log of each side. Then you're going to use the power property of logarithms, which is property number 5. And that property is just saying that if I have a log with a power, the power can become the coefficient. Remember that one? Property number 5. Then you're going to use inverse operations to get x by itself. Okay, what this is going to make is our exact answer. So this is going to give us our exact answer. And then we're going to use a calculator to evaluate, and that's going to give us our approximate value. And we're going to practice rounding either to the thousandths to the thousandths or the 10,000ths, depending. Okay. So the steps seem like, oh, that's a lot. It's not, once you start doing it. And as you get better at it, then you can create your own shortcuts. You can combine steps, but to begin with, we're gonna just kind of lay it out as simple as possible, right? All right, so let's dive in to when you cannot make the bases the same. So for example, we have 15 to the 2x equals 36. There's no way that I can have 15 and 36 have a common base, right? Because they don't have, they're not repeated powers, well, repeated multiplication. So step one is to make sure that there's only one term on each side. Is there only one term on each side? Yes, there is. So we're good to go. Check. Step two is you're going to take the log of both sides. So I'm going to take the log of 15 2 to the x equals the log of 36. Okay. Step three is you're going to use property number 5, the power property that says that I can take my power and turn it into a coefficient. So this becomes 2x log base 15 equals log 36. Step 4, your job is to get x by itself. So if I'm multiplying by 2 and multiplying by log 15, how would I move them to the other side? Divide, right? The opposite of multiplication is division. So I'm going to divide by 2, and I'm going to divide by the log of 15. What that does is it leaves my x by itself. But what I do to one side, I have to do to the other. So we have log of 36 divided by 2 log 15. So we moved it to the other side. This is our exact answer. Log 36 divided by 2 log 15 is your exact answer. Step 5 is to evaluate using a calculator. So we're going to get an approximate value using our calculator. As of right now, we're going to use Desmo Scientific because we don't have any handhelds in our classroom. So I'm going to go to Desmo Scientific and I'm going to type in log 36 divided by 2 log 15. And that's what this looks like. So log 36 divided by 2 log 15. Okay, so we have, if we're rounding to the nearest thousandth, it would be 6.662. If we're rounding to the nearest 10,000th, it would be 0.6616. So we're gonna do the 10,000ths to be a little more accurate. The more decimal places you round to, the more accurate you are. So we have 0.6616. And that's our answer. How do we feel about the 5 steps so far? Doable? All right, so we're gonna go through them again on number 2. So again, step 1 is you wanna make sure there's only single terms on both sides, which there are. Check. Step 2 is you're gonna take the log of both sides. So we have the log of 6, 4 to the x equals log 63. After we take the log, we're going to apply property number 5, which is our power property, saying that our power can become a coefficient. So we get 4x log 6 equals log 63. Step 4, we need to get x by itself. So if I'm multiplying by 4, the inverse of that is to divide by 4. If I'm multiplying by log 6, the inverse of that is to divide that. So what I do to one side, I do to the other. So x is now by itself. And we have log 63 divided by 4 log 6. Again, this is my exact answer. So we're going to use our calculator to get our approximate answer. So I'm going to go to the calculator. So control screen. And I'm going to type in, I like to just go ahead and click the fraction. And I'm going to type in log log 63 divided by, what was it, bottom one? 4 log 6. I write that correctly. Hit enter. And I get, so this one, if I round to the nearest 10,000th, that 8 is going to turn the 0 into a 1, right? Agreed? Okay. So then we end up with 0.5781. So 0.5781. And that's our approximate value. Still filling it? What are your questions, comments, or concerns? Now, the beauty about log is that this works even if the bases can be made the same. So let's just say you're not good at breaking down numbers, like 243. You could technically take the log of both sides and then proceed from there. Okay. All right. So this one, we're going to do just a little bit faster. See if we can just kind of shortcut our way through it, right? So this is example number 3. I look and I see that there's no hope. So I'm just going to jump straight into the log. So I have log 5. The power is going to become the exponent equals log 2,115. And I'm going to divide 4 log 5. Cancels that out. Divide 4 log 5. And I'm going to get the approximate value. So steps are to help you build up to this, right? Do you have to go exactly 1, 2, 3, 4, 5 every single time you do it? No, that's for us to learn. So what do we get when we do log 2015 divided by 4 log 5? So log 2015, perfect, divided by 4 log 5, and you said 1.1894, and you are correct. You're a genius. So I'm going to write 1.1894. Okay. So what I want for you to do is I want you to do 1 and 2 in your notebook. We're going to quickly go over them, and then we're going to do 3 and 4 together. Okay. So quickly do 1 and 2, and then we're going to go over them, and then we're going to do 3 and 4 together. But as you finish 1 and 2, before we go over them, I would like to challenge you to try 3 and 4. I've started them already. All right, so let's see what we did. So on the first one, just kind of quickly, you would have n equals log of 49 divided by log of 9. Agreed? And then you plug that in. On the second one, r would equal log of 51 divided by log of 6. Yes? All right, so those two went fairly quickly. Now, on the third one, notice that when it said that step 1 is to make sure that you have one term equal to one term. Well, I had 5 times 18 equals 26/5. So the 18, the power wasn't by itself. So we had to divide by 5. And that's where you end up here. Okay? It was 5 times 18. Yeah. And so that's why it became 26/5. So now you're left with 6x log 18 equals log of 26/5. And you want to leave it as a fraction. So then you divide by 6 log 18 and divide by 6 log 18. And that's what you're putting in. And then you get your x is approximately something. Okay. All right, and then on 4, notice before we did anything, I had to subtract the 3, which left us with 78. Now this one's really important. When you're moving n plus 10, you're moving them together. And because they move together, they're in parentheses. And that left us with log 9 equals log of 78. Oh, yeah. Divide by log 9. Now, how do you move a plus 10? You minus the 10. So that you can know what to do. So that's your exact, and then you put in the calculator to find your approximate. These are what your exacts should have came down to. Okay, 4 would probably be the quote unquote hardest it would get. All right, have a great 4-day weekend. Correction, 3-day weekend. We have school on Monday. Only other schools do not have school on Monday. Are inverses of each other. That's what property numbers 1 and property numbers 2 of our notes told us, is that they are inverses of one another. So we're going to rewrite with one term on each side. So you want to make sure that your log with variable is by itself. Okay, so we want to make sure the log with the variable is by itself. They're going to take the exponential function of the same base on both sides of the equation to undo the log function. That's our properties number 1/number 2. So if I have log base 2, that means I'm going to raise it to the second power. If I have the common log, that means I'm raising it to the 10th power. So then we're going to solve, and we're going to use inverse operations, inverse ops. And we're going to model it algebraically and graphically. The stuff in the red is totally optional to write. It's just what I'm telling you. So you do not have to write it unless you want to. All right, so we're gonna get started. So for this example, there's more than one way of solving this, okay? We can solve it by making 3 a power, or we can solve it by dividing by 3, okay? To me, it seems that the easiest way of doing it is to make 3 a power maybe and see what happens. But again, you can also divide by 3 and go from there. So I may just model both. All right. So first step here is to use property, because number 1, property number 5, and turn 3 into a power. Now, because 3 is becoming a power, it's going to affect the 2 and the x. So that leaves us with log, what's 2 to the 3rd? X to the 3rd equals 4. And that gives us log 8x to the third equals 4. Okay, so now our log is completely by itself. So step 2 is to now take the base and raise the function to the base. So my base is invisible, but it's a 10, right? So I'm going to raise this to the 10 and raise this to the 10, which is property number 1. So because it's raised to the power of the log, it's raised to the base of the log. These are going to cancel each other out. And we're left with 8x to the third equals 4. A 10 to the 4, not just 4. Missing some numbers there, guys. 10 to the 4th. Okay, so here, what would you do to get x by itself? Move stuff around. Oh, okay, good call, good call. So what we're gonna do is we're gonna divide by 8, agreed? So we get x cubed equals 10 to the 4th divided by 8. How do you cancel out a cube? We're on step 3, I'm sorry. How do we cancel out a cube? No, we take the cube root is what she meant to say. So you take the cube root of the numerator and the cube root of the denominator. And that is x equals, when you're taking the cube root of variables, that just means you are, anyone remember? What does that mean is happening? You're just writing as a power, right? So that just becomes 10 to the 4 thirds. And what's the cube root of 8? What number times itself? 2. So this is our exact answer, this guy right here. So that's our exact. So then to find the approximate, we're going to plug it into the calculator. So we're going to go to handy dandy calculator. I can't stand it. All right, I'm going to clear all. Clear all. So we have 10 to the what? 4 thirds divided by 2. And then we hit enter and we get approximately 10.772.
Oh, this, okay.
The answer?
No.
Well, the process?
Yeah.
Yes. So we get 10.772. And then step 4 is to check yourself. If I plug this back into the original, do I get 4? And the answer is yes. The beauty about using a calculator is you can copy and paste, right? So if I wanted to check myself, I would type in 3 log parentheses 2 times, and I can copy and paste this. So I'm going to copy and I'm going to Control V. And do I get 4 as my answer? Yes. So what does that tell me? I did it right. Bam, got it. Answer is 4. All right. Now, what I wanted to tell you is that, remember I told you there's more than one way of going by this problem. So I'm just going to do it really quick and really fast in this little space right here. So if you chose to divide 3 first, so you would have been left with log . I don't know why I just closed out on me. You would have been left with log of 2x equals 4 divided by 3. Then you would have taken the 10, canceled out, and you would have been left with 2x equals 10 to the 4 thirds divided by 2. And is that not what we did? We went through all this to get. Yeah, right? So in essence, isn't it better to kind of just move everything away from the log and then proceed? If not, could you go through this route? And we're still ended up in the same boat, right? Do we see that? So just wanted to throw that out there. All right, so let's do it number 2. So number 2 is the log by itself. Yes, good to go. So step 2 is you're gonna raise it to the power of the base. Well, the value of the base. So if there's no base there, then what is it? 10. So we're gonna raise each side to the 10 to that power. What happens with the log and the 10? They cancel because they are inverses of each other. So we're left with 4x plus 10 equals 10 to the third. What is 10 to the third? Well, that means you have 10 times 10 times 10. What is 10 times 10 times 10? 1,000. 1,000 is 1,000.
Are you recording?
Yes. So step 3. What do we need to do to get x by itself? What do we need to do to get x by itself? Move what? What's the first thing I need to do to get x by itself? Subtract 10.
I am so embarrassed. I did not mean to cut. I'm sorry.
So we have 4x equals 990. Nope. Raw footage. All right. Now what do? Now I divide by 4. So let's do some shorthand division. 4 goes into 9 how many times? With the remainder of 1, right? 4 goes into 19 how many times? 4, right? Because 4 times 4 is 16. So it goes in there 4 times with a remainder of 3. 4 goes into 30 how many times? Where are y'all multiplication skills at, guys? 7 goes in there 7 times. And there's nothing else. So there's a remainder of 2. So it's 2 out of 4. And look, we just did shorthand division. So 247 and a half. That's what your x equals. Exactly. Who taught me shorthand division? My 4th grade math, my 4th grade teacher.
Ms. Young. Ms. Young,
Was it he?
can you please mute that video?
No. All right. So then step 4 is to check yourself. And so if I wasn't very confident with my answer, what should I do? Check it, plug it back in. So I'm going to go to the calculator and type it in. Log parentheses 4 times 247.5. What was it? Plus 10? Plus 10. Does it equal 3? Yes, you're a genius. Good job. All right. So that's all 4 is saying is that it's an equation. And the beauty about equations is that you can check yourself. All right. Now, examples 1 and 2 are what we consider simple because they only have 1 log in them. Right? Now, if you look at 3 and 4, examples 3 and 4, there's more than 1 log in each one of them. For some reason, again, PowerPoint decides to renumber my problems every single time. I don't know why. All right, so on problem number 3, we need to condense this down to 1 log, okay? And we're gonna do that by using property number 4. When you're subtracting 2 logs, how can you combine them to 1 log? That was on 7.6 notes. How did we combine? Subtraction led to division, Miss Jones. Subtraction leads to division. So that means it becomes log of x plus 9 divided by x equals 3. Okay, So we use property number 4. And now we're on step 2. Step 2, we're going to use property number 1, which says we're going to raise this to the 10th. But this will 10 to the log. And what happens when we raise it to the 10? It cancels out. So we're just left with x plus 9 over x equals. And what did we say 10 to the 3rd equal? 1,000. Right? Okay, so step 3 is to solve for x. So going back to our algebra skills, what do we need to do to start solving for x? Thank you for stating the obvious. Yes, we need to move some stuff around. What do we need to move first? The x in the denominator. Before you do anything, you got to move the x in the denominator. So we have to multiply. And what I do to one side, I do to the other. So this cancels out, and we're left with x plus 9 equals 1,000x. Now what do we do? That's what you should do. You're going to combine your like term. So you're going to subtract 1x. If you have $1,000 and you spend $1, what are you left with? 999. All right, then what's the last thing we do? Divide. And what does that reduce to? It reduces to 1 over 111. 11.
Okay, that's good. We don't need to check the next problem.
So you don't need to check? You believe in yourself?
Yep.
All right, so feeling pretty confident.
What does that mean?
Okay. All right, so you know how they say there's more than one way of doing things? There is. Number 4, there's a lot of ways to do example number 4. Not a lot, there's like 3, but that seems like a lot mathematically. So how do you want to do? If you were looking at this and you're like, oh my gosh, what would you want to do first? Property number 5, right? So number 1, I'm going to use property number 5. Property number 5 allows me to do this guy, right? Take my powers, I'm going to take my coefficients and turn them into powers. So we have log 4 squared minus log 3 plus log x squared minus 4 equals 0. Okay, my job is to combine them to one log. When you're combining, when you're condensing, you want to work from left to right. Does that make sense? So from left to right, I have 4 squared minus 3. So in terms of log, this is still number 1. In terms of log, I'm going to use properties number 3 and number 4. Number 4 is for subtraction. Number 3 is for addition. Okay. This guy right here, he needs to go away because does he even have a log? No. So he's being shipped to the other side of town. So we're going to work it from left to right. So we have log of 4 squared divided by 3 times x squared equals 4. So subtraction became what? Division, and addition became multiplication. And why did we move the 4? Because it didn't have a log. Now I have one log. So now I can go to step 2. In step 2, I'm doing what? Raising it to the base, right? And what is our base? 10. So we're going to raise it to the 10th power. And what I do to one side, I have to do to the other. So what happens to the log in the 10? Cancels out. And we're left with 4. Can I just write 16? Is that okay? Everyone understands that 4 squared is 16. Just making sure. Just making sure. Just making sure. Yura, what is 10 to the 4th power?
Don't be putting me on the hot spot like this.
It was the answer you said the first time. There you go. There you go.
That was just a minor mistake, you know, Jesus made a mistake typing Albert Einstein.
I don't know how to respond to that, so I'm just gonna keep going.
Miss Jones, you get the cookies.
All right. So how do I get x by itself? Multiply by the what? Starts with R. Reciprocal. So we have 3 over 16. Cancels out on this side, and we're gonna multiply 3 over 16. So we're left with x squared equals 30,000 over 16. I'm just making sure you know. 3 times 10, I got that. I'm good.
Don't do that.
I'm good. All right. And then what's the last thing to get x by itself? The square root. So we're gonna get x equals the square root of 30,000 divided by 4. What is that? Calculator peeps. Do we know why I wrote 4 instead of 16? Okay. Why? I square root. Perfect.
So if you keep 16 in there, it's gonna be wrong.
As long as you put the entire thing under the square root, no. Yeah. So the square root of 30,000 divided by 4, I'm gonna go. So square root 30,000 divided by 4, hit enter, and I get 43.301. Now, if you wanted to do the whole thing, you would have to put the square root, and then you would have written 30,000 divided by 16. So as long as it's all underneath the square root, then you're fine. So we get 43 and 301 10,000. We're round to the nearest 3 decimals.
All right, we finish them tomorrow.
So we have x equals approximately 43,301. Approximately. Those are my approximations. And again, if I didn't feel comfortable, what would I need to do? Check it. Now that's a lot to plug back in. But so I feel pretty good about my answer.
Miss Jones, what goes on page 148?
Your extra practice that we've been doing in our notes. All right, we're gonna at least do one of the real world problems. Okay, so we have the enrollment at a private school was initially 120 students and has been increasing by 30% each year. Formulate a logarithmic function t of x that approximates the number of years t it will take before the enrollment reaches x students. All right, so step 1, we have to start with in order to get to the log, based on the information, we're gonna start our exponential. So we're gonna start our exponential function. And our exponential is the opposite of our log. So instead of t of x, it would be x of t. Because they're inverses of each other, right? Your independent and your dependent switch places. So we would have x of t. So our initial, it says initially you have 120 students. You're increasing. So you're increasing, which means that you have your 100% plus your 30%. Which equals 130%. And so as a decimal, what is 130%? 1.3. So that's our exponential model. All right, so now we want to find the log model. So to find our log model, we're just going to take the log. So our goal is to solve for t. So if we want to solve for t, we'd have to take the log of both sides, right? So that would give us, well, we got to get t by itself. So in order to get it by itself, we need to move everything outside of the exponential. So what needs to be moved? 120. How do you move 120? It's multiplication, so the opposite of it is division. So we're dividing x by 120. So we have x divided by 120 equals 1.3 to the t. Now that my exponential is by itself, I can take the log of both sides. So that's going to give me the log of this one. and the log of this. I'm just gonna squeeze it in there. I'm gonna get in where I fit in, right there, okay? What the log does to the, what's this side? Right side, is it allows our power to become our coefficient. So we have log of x divided by 120 equals t log of 1.3. Huh? Which part? This right here? The log? So the log part is property number 2. It tells us if we take the log, it allows us to free the exponential. So we use that, and that allowed us to free our exponential and use property number 5 to move it to the coefficient. And now we're here, and the goal is to get t by itself. So what would I need to do to get t by itself? This is multiplication, and the opposite of multiplication is divide. So divide by log 1.3. So now t is by itself. So our log model is t of x equals, what does division mean for exponentials? If I want to expand it, it becomes what? Subtraction. So it becomes log of x minus log of 120 divided by log of 1.23. And that's property number 4 that makes it expand. So now this would be your log model. Okay. Well, then we can go back over it tomorrow. You can ask questions so that hopefully it makes more sense. But it's a
Did you sign my paper?
before the enrollment reaches X students. All right, so the problem here is that it wants a log function, but we don't start off with enough information for a log function. We start off with information for an exponential function. We have an initial amount and we have a rate. That lets us know that we can start off with an exponential model. Okay, our exponential model is usually with our amount equals our initial principal A naught, what do you want to call it? 1 plus our rate to the t. Y'all remember kind of doing this in 7.6? All right, so for this problem in particular, instead of it being t of x, it would be x of t equals, and what's our initial amount? 120. And what is the rate we're growing at? 30%, so 0.3, right? So our exponential model is 120 times 1.3 to the t. That's our exponential. But what did this problem want? Our logarithmic model. So our log model means that we need to solve for t. So our goal is to get t by itself. In order to get t by itself, so right now we have x equals 120, 1.3 to the t. In order to get t by itself, this has to be all by itself before we can start anything, which is what we did on the other side of our notes. So we're following the steps for different base, I guess. Yeah. So we're going to divide by 120. And then we're going to take the log of both sides. The reason why we take the log is so that t can no longer be an exponent. Does that make sense? So we have the log of x over 120 equals the log of 1.3 to the t. This is going to free our t, and this allows us to become log of x minus log of 120 equals t log of 1.3. So we use property number 5 and property number 4. Division became subtraction. And what's the last thing we got to do to get t by itself? divide the log, right? And what you do to one side, you do to the, and there's our equation. So here's your T of X. Okay, the benefit of this equation is that if they have a goal of how many students they want, they then can use this equation to figure out, approximate how long it'll take them to have that many students, which is what the purpose of the equation would be. So if our goal was to have 500 students, how long would it take us to have 500 students? So we plug in X equals 500 and solve from there. Okay. Your last word problem, the last one is just you doing the 500. So remember how I just gave you that example? So now that we have the formula, can you calculate how long it'll take for them to have 500 students? Yes. So you're just plugging in T of 500 equals log 500 minus log 120 divided by log 1.3. So you're now calculating.
So what about the number 7 question?